In this video, we discuss about bit and bytes. Okay, what is bit and what is byte in the computer language? Okay, say for example, so the computer can understand only 2 bits. That means it can understand, because it's a voltage operated device, so it can operate in only 2 voltage levels. So like voltage I, that we call 1, and voltage level 0. This is like 0 level, 0 volt. This is like, depending on the computer voltage levels. Let's, just for the simplicity, we try to understand 3.3 volt. Okay, same here, this is 0 volt, this is 3 volt. So the low level is 0 volt, the high level is 1. 0 volt is 0, high level is 1. So computer can understand only 0 and 1 language. So in our decimal system, we have 0 to 9. This is the decimal system, our normal decimal. But computer understands only 0 and 1. That means it's called binary system. So whatever we feed into the computer, that will be converted to 0 and 1. All the information we feed in, the numbers, alphabets, numbers, special character, everything will be feed into the computer. Whatever we feed into the computer will be converted into 0 and 1 format. That means binary format, and it will use as required in the computer system. It will use the computer circuits to understand the 0 and 1, and it will convert meaningful information, whatever required by the user, it will be converted for the meaningful information. So first we understand how we convert decimal system into binary. Then we understand how system will convert these 0 and 1 into meaningful information, and how computer will be used this binary system data for the processing of the information and convert and give the output to us based on the information we put in. Okay, say for example, in 0 to 9 format, that means decimal format, we given 6. We know that 6 we can understand. This will be converted to binary system, where only 0 and 1 will be available here in this system. Okay, how we convert? So because we have only 2 digits, that means 2. Binary system is 2. Binary by is, the by means 2, that means only 2 digits are available, 0 and 1. Okay, these are called bits, 0 and 1. And how to convert this to binary? So use this 2. 2 3s are 6. The remainder is 0. Then again for the 2 1s are 2. 2 1s are 2. Remainder is 1. This 1 1 0. 1 1 0 means the binary digits equivalent to 6. 6 is converted to binary system 110. Now how to convert back 1102 into 6? Okay, here in the, you know that in the decimal system, we know that 10 to the power of 0, the first digit, 10 to the power of 1, the second, 10 to the power of 2, like this it will go on. So 10 to the power of 0 means 1, this is 10, this is 100, and this is 1000. Like this will go on. Okay, but here in the binary format, we have 2 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. That means this is 1, 2, 4, 8. So you can see that like this will be into 10, this is into 2, this is into 10 in the decimal system, this is into 2. So the each face value will be multiplied by 2 to get the next place value. So 1, 2, 4, 8, 60, 32, 64, it goes on like this. So like this, to convert 110, so 1, 2, 4, that means 1, 2, 4. The first digit will be multiplied with 1, the second digit will be multiplied with 2, third digit will be multiplied with 4, like that. This will go on. Like we do, like in the decimal, right? We multiply with 1, the first digit, second digit will be multiplied with 10, so third digit will be multiplied with 100, like that. We need to know this 1, 2, 4, 8 and into it. So now 0 into 1, 0, 1 into 2, 2, plus 2, 1 into 4, 4. Now 4 plus 2, 6, 6 plus 0, 6 again. So 6 is converted. 110, we can convert like this by multiplying with the number. Let's try with some other number here. Some bigger number, maybe 15. Okay. Let's try with 15. This is decimal. We convert this to binary and convert back from binary to decimal. 15, 2, 2 sevens are 14, 1 is the remainder, 2 3s are 6, and again 1 is the remainder, 2 1s are 2, then 1 is the remainder. So 1 from here, this way. So started here, 1 1 1 1. 15 means in decimal the binary is 1 1 1 1. Now we will convert back. Try to convert. That means 1 2 4 8. We'll try to multiply. 1 into 1 1, 1 2 is a 2, 1 4 is a 4, 1 8 is a 8. 8 plus 4 12, 12 plus 2 14, 14 plus 1 15. That means, so this converted back from binary to decimal also, decimal to binary also. This way we can easily convert. So whatever. So now we'll try to understand the easy method. Now 14 is there. We know that 1 2 4 8 is going on. So now for the 14, we can enable these two bits, 8 for plus 4 12, 12 plus 2 14, 0. So 1 1 1 0 will give 14. So this way we can also do the reverse engineering and convert. Say now for the 12. Okay. For the 9, 8 4 2 1. 9 means 8 plus 1, 9 will happen. So 1 0 0 1. That means 8 plus 1 9. So for the 9, equivalent is 1 0 0 1. Now 10, 1 0 1 0. That means 8 plus 2 10. So like this we can convert easily from binary to decimal, decimal to binary. Okay, that means only 0 and 1 are available in the computer world. So in the binary system, now we discuss how we can utilize this 0 and 1, how we can convert meaningful information out of 0 and 1. Okay, say now these are the 8 bits here. That means this can be 0 or 1. Like this, the every bit, this is called bit. So each bit can be either 0 or 1. So based on the 0 and 1 position, we calculate total of this and we find out decimal number of this. Okay, this why 8 bits? Because 8 bits means 1 byte. 8 bits means 1 byte. Say now 18. Now I want to convert. Let's take 13 as an example. Okay, and here 2, 4, 8, 16, 32, 64, 128. So 13 means 8, 4, 12, 12 plus 1, 13. 0, 0, 0, 0, 0. This is for the 13. Okay, the output is 13. Okay, so 1101 is 13. So remaining 4 bits we need to fill 0 because we need 8 bits to make it 1 byte. Now for the 13, in the bits, decimal number is 13. This in the bits binary number system 00001101. This is the binary number for the 13 expressed in 1 byte. So normally the bits in the binary system always expressed in bytes. So 1 byte is 8 bits. And so this way we convert everything, whatever alphanumeric system we have, the decimal system can be converted to binary. And so in this way okay, so if you fill 1 1 1 1 1 1, so all the ones, that means 1 2 4 8 16 32 64 128. That means if you calculate 120 1 into 128 plus 1 into 64 like this plus 1 into 1 up to this, you will have 255 total. That means in this way we can have two numbers up to 255. What if we need the number more than 255? Then we need to add one more bit here, that is 256 here. That means we can have maximum 511 here up to. So with this up to 511 we can calculate like this. If you want some more, we can add one more bit like this. So but in the order of 8 bits. So 8 bits, the next is 16 bits, 24 bits, 32 bits. Like this, multiple of 8 bits we can add, and we can have 8 bits format, 16 bits format, 24 bits format, 32 bit format. So modern compiler and modern CPU will have 32 bit length. All the calculation will happen almost all at the 32 bit level. 32 bits level. That means 32 bits CPU. That means 4 bytes CPU. All the CPU registers, the memory, everything, even the integer, you know that the integer is 4 bytes, that means 32 bits. So everything most probably on the 32 bit CPU. The modern CPUs are the 32 bits. So the 32 bits is, bit is very important. We'll understand step by step how we convert. So same way, like we converted 13 bits into 1 byte data, we can convert into 4 byte data. and use it for our information, where CPU will convert everything, calculation, everything will be applied based on these 4 bytes. 4 bytes, that means 32 bits. Now we know that 1 byte is 8 bits. For the 4 bytes is 32 bits. Okay, here 4 bytes will be in this order. 0th bit starts from the right here, 0 to 7, the first byte. That means here in the C word, normally it start with 0, like 0th byte, here 0th bit. 0 to 31, that means for 32 bits it's 0 to 31, and 4 bytes is a 0 to 3 byte. That means 4 bytes, 0 to 3, and 0 to 31 for 32 bits. Okay, this is how the in C word we will understand about the 4 bytes. That is for 32 bits will be there for integer, and for the float everything is mostly on the, it works on the 4 bytes, because modern computer, our latest CPUs, most probably on the 4 bytes structure will be there. The CPU architecture will be on the 4 bytes for 32 bits or maybe 64 bits. Just for the simplicity, we try to understand the CPU that we are using, the compiler that we are using is for the 32 bits. That means for the 4 bytes architecture. Okay, and so now we try to understand how these bits will be processed in the computer. So there are 4 basic gates available in the C language: AND, OR, XOR, and the NOT gate. These are the 4 gates available in the computer, where the bits that we are providing as a user input will be processed and provided, then used for useful information. Okay, so for the AND gate, 2 inputs will be there like this, 2 inputs, and AND gate will be process these 2 inputs and gives the output. So these 2 are the input and this is the output. So here for the AND gate, when both inputs are 1, then output is 1. That means when both are 1, the output is 1. Otherwise, in all other case, if input is 0 0, output is 0. If input 1 and input 2 is 0 1, then output is 0. Like this, input is 1 and 0, then output is 0. When both are 1, the output is 1. See, that is what, when both inputs are 1, then output is 1. That is for the AND gate. Okay, then the next gate is OR gate. Okay, here when any one of the input is 1, then output is 1. That means if in these 2 inputs, if any of the bit is 1, say if both are 0, then the output is 0. If any one is 1, here output 2 is 1, the output is 1. Here output 1 is 1, then output is 1. If both are 1, yes, definitely output is 1. So for the OR gate, when any of the input is 1, then output is 1. So there is a OR gate. It looks like this, and you can give input 1 and 2 based on our requirement. So next is XOR gate. When inputs are opposite, then output is 1. That means when inputs are opposite, 0 and 1, this is the opposite input, that means the output is 1. When inputs are same, 0 0, then output is 0. So here, okay, this is actually 0. So here inputs are opposite, 1 and 0, then output is 1. Inputs are same, 1 1, the output is 0. So XOR gate looks like something like this with the 2 inputs. So XOR will have output like this, 0 1 1 0 for the input. And last but not the least is the NOT gate, where input, then the NOT gate, then the output. Whatever input you give, the opposite you get. When you give input 0, the output will be inversed. That means 0 will become 1, 1 will be converted to 0. That is the NOT gate. So these are the basic gates available in the C. Let's understand this with a program, how this will look like. This gate will be implemented, how these bits and bytes will be used in our C language with a proper example in the C. So here we take a real example, C programming, a real-time example where two integers a and b, a assigned with 6 and b is assigned with 3, okay, and in the computer, in the CPU, this 6 will be converted to the 32-bit binary, and this will be represented as 110. As you know how to convert the decimal 6 into binary digits, and same as decimal 3 into binary digits. So this will be converted to 311 in the 32-bit binary. So this 8-bit zeros, then again 8-bit zeros, 8-bit zeros. So all zeros, but last two bits will be 11, and here last 3 bits will be 110. So this is the A and B represented in the CPU. So now will result is equal to A and B. That means this is AND gate in C actually. So this is A 0110. Just for the simplicity, we take only 4-bit instead of the for 32-bit. We take only 4 bits here, 0110 for A and 0011 B. A and B. This is A AND gate, this is a AND gate, and B. So this will be converted. So this first 0 and this first 1. So these are the two inputs here, input on input 2, and for the AND gate, when 0 and 1, that means 0 and 1, the output is 0. Yes, here the output is 0. And for the second bit here, the next bit 1 1, when both are 1, the output is 1. Yes, the output is 1 here. And the next bit 1 here, the input 2 is 0. That means 1 and 0 here. 1 and 0 means output also 0. You can see output 0 here. And for the last bit 0 and 0. When both are 0, the output is 0. The 0, that means the output is 0010. If you convert back this back to the decimal, the output is 2. 0010 is 2 actually. When try to print AND result, the result is 2. You can see the result here 2. The same like this we do it for A, OR gate, B. This is OR gate in C actually. Okay. So A is 6 and B is 3. 6 or 3. So this A and B will be converted to binary, and this binary OR gate will apply, and this OR gate will be used like this. And if you see the each binary digits will be considered, and the output will be 0 111. The 111, if you convert back to the decimal, the output will be 7 here. You can see here the R result is printed 7. Same for the same like we do it for A and B XOR gate. This is the XOR symbol in C language. Whenever we do A and B 6 and 3 with the XOR gate, so the output will be 101. And if you convert back 101 to decimal, is a 5. So it's printed 5. XOR result is 5. Okay, here XOR. Okay, then for the complement, this is the NOT gate actually. So NOT of A. So NOT of A actually, when you convert 0110, that is NOT of A, it will be converted as 1001. This is actually -7. So in C, the convention to use 6 complement will give -7. So NOT result is -7. So this is a this is how the C will calculate the NOT gate. So NOT of B here, NOT of B means NOT of 3, 1, 1. So 1 will be converted, all the 0 will become 1, then 1 will become 0. So 0, 0, 1, 1 will have 1, 1, 0, 0. This is actually 5, but in the C nomenclature, this is minus 4. So NOT of result is minus 4. This is how C can be used for decimal to binary conversion. Then binary will apply this AND OR gate, XOR gate. Then the output will be printed back in the decimal using the integer format specifier. So decimal can be printed. Okay. So this is about the bitwise operator, how bitwise operator will work in the binary system. Okay, left shift operator. So I'm trying to do left shift operator here. A left shift by 1. Okay, A is 0, 1, 1, 0, 0, 1, 1, 0. So when you do left shift by 1, that means we try to understand from here. So this is 0, 0, 8-bit data, 1, 1, 0, that is A. When you do left shift operator, left shift operation by 1, that means every bit in this here, original bit, will be left shifted by 1, like this. So this will be shifted here, this will be shifted here, like this. This one will be shifted here, this one will be shifted here, then 0 will be shifted here, one more 0 will be added here back. So that means now the after left shift by 1, 6 is become 12 actually. That means C, that 12, the left shift by result is 12. So 1, 1, 0 become now 1, 1, 0, 0, that is 12. So same operation. So like now I'm trying to do right shift by 2. So when you do 0, 1, 1, 0, 0, 1, 1, 0, right shift by 2, so this will be go out and this will be go out and this 1 will come here. So all the zeros will be added here. So 0, 0, 0, 1. That means the output is 1. So 0, 0, 0, 1, 1, 0 will become 0, 0, 1. That is what is printed. The right shift by 2, 6 become 1. So this is about the right shift operator. So all the bitwise operator. So this is about the operations of all bitwise operator. Thank you.